Bismillahirrahmanirrahim. This is October 2010, waiting 42, question number 4. Topic is work power energy. Mass is 20 kilogram and distance it has to travel 10 meters. So from bottom to top. Okay, speed is here 2.5, here 1.5. So loss in kinetic we have defined. So it's a simple way. So loss in kinetic energy we can find like this. Loss in kinetic energy. Naturally here is bigger, here lesser. So I can say that half m u square minus half m v square. So half into mass is a 20, u is 2.5 and mass again 20 and v is 1.5. So half into 20 into 2.5 square and minus 1.5 square, it gives answer 40. So 40 joules is our first part answer. So let's go for the other one and gain. So gain in potential energy, how much? So gain in potential energy, mgh on the top and minus mgh on the bottom. So bottom 0. Mass is 20, g is 10, height we don't know. So let's say this is the height, 90-degree height. So opposite by hypotenuse will give us the height. Like I'm finding here, opposite by hypotenuse give you sine theta. So multiply is there. So h is 10 times to sine 4.5 will give us the height. So I can write directly 10 times to sine 4.5 is this one, and this 0 because it's the bottom. So let's find 200 and into sine 4.5. Answer is coming 157. So 157 is our answer and 157 joules. Come on this part, he said that from here to there, work done against friction force 50 joules and find out the work done by friction applied force. So you know the magic formula I discussed, applied force, and this is called net work done, okay, equal to mechanical energy, kinetic energy plus potential energy at a top minus kinetic energy plus potential energy at a bottom. So this is you can say net work done is equal to change in mechanical energy. So this is my question, so I'm leaving as it is. And this is given by 50 joules. Okay, kinetic minus, if I open the bracket, so kinetic energy at a top plus potential energy at a top, open the bracket, kinetic energy at bottom and minus potential energy at bottom. So you can see here I wrote here, this is, we have to see that this value is u come before. U is actually Ke at the bottom. So K at the bottom I need before. Before, so it means if I write this negative common from here, so kinetic energy at bottom minus kinetic energy at the top. So this I took negative common, I got it. And from here, nothing to take it, simply potential energy at top minus potential energy at the bottom. I write in bracket. You can see here, this is exactly same. Top minus bottom, top minus bottom. And this bottom minus top because bottom speed is u and this top. So you can see the same link. And this value we have here, I'm writing 157 and this value is exactly 40. So answer is coming 137. 157 minus 40, 117, sorry. So joules. And then let's talk about the next one. Pulling force is at angle 15 degree upwards. So pulling force, this is from the slope. This is slope with a slope 15 degree upwards. So this is 15. So this is a slope. So we can show that this is temporary line. So this is a force angle here 15 degree. So you know that one component parallel to surface, a slope. So F cos 15 and one is this one. So F sine 15. Okay.
And you know that this is we have two things acting here. One is a friction force and one is a weight component. And weight component, you know, is a 20, so 200, because weight is a 200. And 200 sine 4.5. Okay, this is a weight component acting downward, friction force downward, and this one. So you can use it. We need a pulling force. So this force is the topic of neutral law converted to. So what is the formula? Net force equal to MA. Net force equal to MA. So we can see here F cos 15 minus friction force, and friction force we have given here. We can see that, yeah, we have given here work done by friction force. I think I can get easily by work done by friction force is 50 joules. If I write F into D equal to 50, and friction force I don't know, but distance throughout from here to here is 10. So 10, so it becomes 5 newtons. So it means that I can say here is a friction force. So that this minus friction minus 200 sine 45. So sine 45, 4.5, sorry, equal to mass is a 20, and acceleration, you know, we can find even, okay? And we have given everything, so let's find acceleration as well. 2as equal to v squared minus u squared, 2 times to acceleration, s is 10, and last speed is 1.5, and u is a 2.5 square. So acceleration is coming from here, 1.5 square minus 2.5 square, and divided by 20. So I got the answer negative 0.2. So negative 0.2, and I can find, and this is a question, this is cos 15, and friction force is 5, so I type all together, okay, 200, okay, 200 sine 4.5, and 20 times to negative 0.2. So let's type all together, so 20 times to negative 0.2, negative 0.2, and this will add plus 200 times to sine 4.5, and this will add, so I get here 16.6918, here f cos 15. So if I divide cos 15 down, so it will give me answer like this. Okay, divide by cos 15, and answer is coming here, so 17.3 newtons. This is my force, and that's it, and okay.